a couple things I want to mark here. All right, on the left-hand side, you've got oxidizing agents. On the right-hand side, reducing agents. So oxidizing agents are the substances that are typically reduced. Does that make sense? Yes? Okay, so you'll notice up here that the strongest oxidizing agents are at the top. The weakest oxidizing agents are on the bottom. Over here, the stronger the oxidizing agent, the weaker the reducing agent. And then down here is the strongest reducing agent. They've also given you the titles up here, oxidizing agents on the left, reducing agents on the right. They've given you the voltages, which we'll talk about soon, for each one of these half reactions. And then we may want to also highlight the halogens as they occur, just so that you have them. What just happened? There's that one. Bromine, chlorine. And then, where's iodine? Here it is. Okay. Those are your halogens. The oxidizing strength actually corresponds to the electronegativity. So because fluorine is the most electronegative, it will be the strongest oxidizing agent. Okay, so you may want to make a note that electronegativity is directly related to oxidizing agent. The strength of an oxidizing agent is called its reduction potential, okay? So reduction potential means its potential to be reduced. So oxidizing agents get reduced. So if you take a look at the right-hand side of the table, they give you the value in volts. So that means if you reverse the half reaction, you will also change the sign on the voltages. Okay, so if it's positive and you reverse it, it would become negative and vice versa. Okay, let's take a look at the quick check on the next page. Or back to the previous page. My page number is 288. I don't know what yours is. I'm going to leave this here, and I'm going to hand write in the quick check right here, just to make it easier. So we've got, we're going to do 1, 2, 3, 4. We're going to skip 5, and then we're going to do 6 and 7. Okay? So number 1 says, which is the stronger reducing agent, cobalt or strontium?
Strontium.
Yeah, you've got cobalt right here. That's chromium, sorry. Cobalt is here. I just had strontium. Strontium is here. So since strontium is further down on the right-hand side, it would be strontium. That's the stronger reducing agent. So all the reducing agents are listed on the right. Number 2, which is a stronger oxidizing agent? Fe plus 3 or Al plus 3?
Fe plus 3.
Yeah, Fe plus 3 is further up. It's right here. And then your Al plus 3 is down here. So you would pick the Fe plus 3 because it's further up on the left-hand side. Number 3, which has the greater oxidation potential? Okay, so we're comparing Br negative 1 with I negative 1. So Br negative 1 is here. I negative 1 is here. And then they gave the values here. So the strength of the reducing agent, they're the opposite of the reduction potentials. So that means you're actually going to pick which one?
I.
Yeah, you would pick I negative 1 for this. And then for number 4, which has the greatest reduction potential? Okay, so for this one, you're looking at CR plus 3, which is, I believe, here. And then SN plus 2. A little bit higher, yeah. SN, which one would you pick? SN plus 2. Okay, let's take a look at 6 and 7. What's the reduction potential of Ag plus 1? So that means what is the voltage? What's the actual number over on the right-hand side of the half reaction for Ag plus 1? Ag plus 1 is right here. So this, this as it is written, this is the reduction potential, okay? So positive 0.80 volts, okay? And then they want the oxidation potential for calcium. Calcium is way down here. Here's its half reaction. But since they're asking us for the oxidation potential, you want to reverse the voltages when assigning the oxidation potential. Okay, so you would want to reverse the voltage for the calcium metal, which would be what? Yeah, positive 2.87 volts. Okay, are we good with that? All right, we've got like one more thing to talk about. Did I take the titrations out of here? Yes, there's only one more practice set in here. Yes, yeah. Perfect. Okay, good. What page number are you on?
292.
Okay. So sometimes they'll give you a mixture of different substances and they'll say, okay, what do you think is going to be the predominant redox reactions based upon what you're given in this mixture? All you're looking for is the substance that is furthest at the top left and the furthest at the bottom right, because this is the direction of electron flow. Okay, so you want the two that are the furthest away from each other on the table. So let's take a look at the last set of practice problems. Is that this right here? Yeah. Okay. this is pretty straightforward. So let's just take a look at number 1. You tell me, which two substances are furthest away on that table? So which one is in the top left and the bottom right?
Sn plus 4 is higher than Cn plus 2.
Yeah, so this is top left.
Ni is lower than Br minus 1.
Yeah. So this is on the bottom right. So that means these other two are irrelevant. They're in the middle somewhere. Okay. So since nickel will give electrons, because it's on the bottom right, you want to reverse that half reaction. So it's going to be nickel metal going to 2 electrons and then the nickel 2 ion. And then you're going to leave the Sn plus 4 half reaction as it is. Is there only one Sn plus 4 on that whole table? I'm just double checking. Because sometimes there's multiple. I see Sn plus 2 underneath it, but I don't see another Sn plus 4. I think we're good. Okay. So these are your 2 half reactions. The number of electrons are the same. So then this would be your dominant reaction taking place. Okay. If for some reason they give you a mixture and like there isn't a way to have a predominant redox reaction, like you don't have something at the top left and the bottom right, it's just no predominant reaction. Okay. There's just nothing to do. All right. That is the end of this section. Do you want to work on this homework before I go and teach you? 6.4 and 6.5 kind of go together. So you want to wait? Sure? Okay. Tackle this homework, ask me questions, and then we'll